Hi everyone, welcome back to YÖS ALFA. Let me take you through the math part of our 5th trial exam. As usual, for those who haven't taken the exam yet, the PDF is available in the description part down below. To get the best out of this video, I suggest you take the exam first before continuing. Let's get started. Number 1. The division is given. We're asked to find C in terms of A and B. Let's write down the division in the equation format. So divisor times quotient plus remainder is equal to the dividend. From here we can solve for C in terms of A and B. BC plus 3B plus 5 is equal to A plus 2. From here we can find C as A minus 3B minus 3 divided by B. So the answer is A. 2. X and Y are positive integers. The word integer is really important. I'm going to explain why later. So we have this expression and we're asked to find the smallest value of the sum x plus y. So let's prime factorize it first. 144 is the same as 1216 times 9, which is then again same as 2 to the 4 times 3 squared. On the right hand side of the equation we have the cubic expression. That means to find y, we need to have a cubic expression on the left-hand side of the equation too. Otherwise, we will be having non-integer values. So to make it cubic expression, we'll multiply this 2 to the 4 by 2 squared and 3 squared by 3. So now we have the expression as 2 to the 6 times 3 cubed, and we can make it the cubic expression this way. So now we have the integer value of y when we cancel out the cubic expression. So y is 2 squares times 3, which is 12. And how about x? X is the terms that we have added to multiply the existing numbers. So 2 squared times 3 is x, which is then again equal to 12. So x plus y is 12 plus 12, which is 24. This is what we were after. So the answer is E. 3. The three-digit number ABC satisfying the condition A greater than B greater than C gives a remainder of 1 when divided by 4. What is the largest value of the sum A plus C? So let's write down ABC satisfying this condition. Since the largest sum is asked, I'm gonna take 9 as A. So the second largest is A, the third largest is 7. And we'll check if this number is satisfying the condition given here. It should give us the remainder 1 when divided by 4. So 4 times 2 is 8. We're left with 18. 4 times 6 is 16. We're left with 2. 27. 4 times 6 is 24, so we're left with remainder 3. So the last term is 27. So to have a remainder 1, we can make 27 25. So instead of 7, the last digit must be 25. Okay, 5. So that we are left with 25 when divided by 4. So now this number gives us the remainder 1. So the answer is A plus C. So 9 plus 5, which is 14. 4. Given that XYZ and ABC are three-digit numbers, what is the difference XYZ minus ABC satisfying this condition given here? So let's write down this expression using the place values. Since x is at the 100th place, we're going to multiply this by 100, and y is in the 10th place, we multiply this by 10 plus c minus 100a minus 10b minus c. Let's simplify this. When we factor out 100, we have 100 times x minus a plus factoring out 10 gives us y minus b plus z minus c. So x minus a from this equation is 2 and y minus b is 1. Z minus c is minus 1. So we have 200 plus 10 minus 1. So the answer is 209. E. 5. A, b, and c are consecutive odd numbers. That means if a is x, then b is x plus 2, c is x plus 4. Now let's substitute these values into this expression. So we have x plus 2 and b is x plus 2. So we have x plus 2 is x plus 4 and c is x plus 4. So we have x plus 6 over here, which is equal to 3. X plus 2 cancel out each other. So that's x plus 4. So we're left with x plus 6 over x is equal to 3. X plus 6 is equal to 3x. X is equal to 3. So x is a. If a is 3, b is 5, and c is 7. So the multiplication of ABC is 105. The answer is B. 6. In this table, the products of the numbers in each row and column are equal. So let's add y y over here. So the product of the column here is 8 times x times y. The product of the row is 4 times y times 12. Y's cancel out each other. We have x is equal to 6. The answer is B. ABC is an odd 3-digit number, and ACB is an even number. Okay, from here, what do we know? If this is odd, that means C is odd. If this is even, that means B is even. We know that for sure. Now, what is the question? The question asks which one of the following is an even number for sure. Okay, A plus B plus C, we know B and C only, we don't know A, so we can't say anything for sure. For the choice B, we don't know A, so we can't say anything for sure. Here, same thing, we can't say anything for sure about A. As for the choice D, we know B, which is even, so even times any number is even, and this is even, so even times any number is even. So now even plus even is also even for sure, so our answer is D. 8. What is the value of x? Let's simplify this. X over 0.3 bar plus 1 is equal to x plus 33. 0.3 bar is equal to 3 over 9, which is 1 over 3. Let's rewrite this equation using this result. So x over 1 over 3 is the same as 3x is equal to x plus 33 minus 1 is 32. So 2x is 32, x is 16. It's B. 9. G of x plus y is given to be g of x plus g of y. We're asked to find g of 9. So let's start with the given expression. G of 3. Since we know g of 3, we can use 3 for both x and y. So g of 6 is g of 3 plus g of 3 since both x and y are 3. So g of 3 is given to be 9. So 9 plus 9 makes 18. So now we know g of 6. How do we find g of 9? To find g of 9, we can use this function as x value 3 and y value 6, since we know g of 6 now. So the result would be g of 3 plus g of 6, and g of 3 is given to be 9. G of 6 is found as 18, so the result is going to be 27. It's C. 10. We have two functions, h of x and g squared dot h of x, and we are asked to find this. To find out h of 2, we need to know the equation for h of 2, which is this point. When x is 2, how much is y? So this is the point that we are looking for. Okay, since this is 45, this is 90, that's also 45. We have an isosceles triangle here. This is 3, that's also 3. Okay, now we can find h of x. It's a linear equation, so the format of the equation is mx plus c. M is the slope. The slope is rise over run. So 3 over 3 is 1. And how do we find c? We can use this point. This point. When x is 0, or y is 3 for the function h of x. So when x is 0, we have c, which is equal to 3. So we have h of x now. So what is h of 2? It's 2 plus 3, which is 5. And how about g squared dot h of x? G squared dot h of 2 is asked. So when x is 2 in this function, what is y? It is the same point as h of 2. So the value is also the same, 5. So we have 5 plus 5 is equal to 10. The answer is E. 11. This equation is given. We are asked to find the solution set. Let's rewrite this expression as x plus 3 is equal to x minus 5. Both are absolute values. If both are either positive or negative, then x will cancel out each other. We'll have 3 is equal to 5, and there is no solution for that. So in order to have a solution set, the only possible case is one is positive while the other is negative. And let's write down this condition. X plus 3 is equal to 5 minus x. So 2x is equal to 2, x is equal to 1. So that's our only solution set. It's B. 12. A is less than B, B is less than 1, and this one is given. We're asked to find the root of this equation. So from this expression, we know that A minus B is less than 0. So this has to be negative. So this becomes B minus A minus 1 plus x. How about this? We know that b minus 1 from this expression, b minus 1 is less than 0. We can write it this way. This expression is the same as a minus 1 plus b minus 1. So this is less than 0. How about a minus 1? Since a is less than 1, a minus 1 is also less than 0. So this is also less than 0. So we have the summation of two terms that are less than 0. So this is definitely a negative. So to make it positive, we multiply it by a negative 1. So our result is going to be this, minus a minus b plus 2. Now let's solve for this equation, these two cancel out each other. X is equal to 3 minus 2b. So the answer is A, 13. The multiplication of these two is 91. What could be the value of the sum x plus y? X and y are integers. Now let's prime factorize it and see what happens. 91 is 7 times 13. Both are prime. So that means either 2x plus 1 is 7 or 13. And let's solve it one by one and see if which of this one agrees with the solution given here. So if 2x plus 1 is equal to 7, then 3y plus 1 is equal to 13. So x is 3 here, y is 12 over 3 is 4. So 4 plus 3 is 7. So we have our answer. Okay, if we started out with 2x plus 1 is equal to 13 and 3y plus 1 is equal to 7, then we will have our solutions again, but it would not be in the given answer choices. So x is 6, y is 2. The summation is 8, which is not included in the given answer choices, although it could well be the solution that satisfies this condition too. 14. X times f of x is greater than 0. This is given, and x values are all integers, and the summation of all the possible values of x is asked. So f of x is y. So x times y is greater than 0. For this to happen, if x is positive, then y has to be positive too. If x is negative, then y is negative too. So let's check the graph. Let's start with x positive region. Starting from here up until here, our x is positive. For every x values, we have the positive y values. So we have both x and y positive in this region. So this is okay. From 0 to 6 is okay. How about this region? We have negative values of x in this region, and for all these x values, the corresponding y values are also negative, because we have y's here. For this point, we have negative y. For this point, we have negative y's. For every single point of x in this region, we have the negative y. So both x and y are negative in this region, so this is also okay. So our solution set is from negative 8 to 6. Is negative 8 included or positive 6 included in our solution set? No, because we don't have equal sign in the given statement, which means when x is minus 8, our y value is 0. Since 0 is not included, our solution set will be between minus 8 and 6. Minus 8 and 6 are not included. So we're asked to find the summation of x values, and the x values are the integers start from minus 7, minus 6, minus 5, it keeps on going, and up until 5. 6 is not included. So starting from here, negative 5, negative 4, negative 3, they will cancel out with the corresponding positive values. So our summation will be left with only these two terms, which is negative 13. So the answer is D. 15. If n is a positive even natural number, what is the result of this operation? So minus 1 to the even number is plus 1. Minus 1 to the odd number is minus 1. And there is already minus over here, so plus 1, and minus 1 to the odd number is minus 1. Minus 1 to the odd, since n is even, so this is even, so minus 1 to the even power is plus 1, since there's negative, so we have this. So the summation of these four numbers gives us 0 as a result, so the answer is E. 16. A is a negative number. How many of the following are positive? This is the same as 1 over a. Since a is negative, this is also negative. This one is 1 over a squared times minus 1. A squared is positive, times minus 1 is negative. Minus 1 over a cubed. Since a cubed is negative, times minus 1 is positive. And this one is minus 1 over a to the 8. A to the 8 is positive, times minus 1 is negative. This one is a to the 8, negative to the 4 is positive. A to the 8 is also positive, so this one is positive. So two of the given choices are certainly positive. Our answer is B. 17. Let's simplify this. 3 to the minus 2, and this becomes plus 3. The negative is already there. And 2 to the minus 6, this one is negative. And 2 to the minus 6 again, it becomes positive. So the final result is minus 3 to the 1 minus 2 to the 0. So minus 3 minus 1, which is equal to minus 4. So the answer is A. 18. What is the smallest integer value that a can take? So this inequality is given, and we have 5 over 2 here. I'm also going to change it so that we have 5 over 2 on both sides of the inequality. So 5 over 2 to the minus 1, and we have 5 over 2 to the a minus 14. Since the bases are larger than 1. If this one is larger than this, then we can talk about their powers the same way too. A minus 14 must be larger than minus 2a plus 3. Now let's solve for this inequality. We have a larger than 11 over 3, which is 3 point something. Okay, a has to be integer, and the smallest integer that is larger than 3 point something is 4. So the answer is B, 19. So we need to notice this thing here. We have k minus 2 root 3, and here we have 2 root 3 minus k. So they are the reverse. It's like writing square root of a and square root of minus a in one expression. And we know from the definition of the domain of the square root that whatever is inside the square root has to be greater than or equal to 0. Now, to satisfy this condition, a has to be 0, since minus 0 is also 0, so square root of 0 is also 0. Other than that, all the other real numbers will give us the complex solution for this. Since we're dealing with only the real numbers, because the answers choices are given in real numbers, we know that k minus 2 root 3, which is a in this case, has to be 0. So k minus 2 root 3 is 0. That means k is 2 root 3. And this term is gone. And that one is also gone. We are left with k squared over k only, which is k. K is this. So our answer is D. 20. What is the result of this operation? Let's simplify this one. 0.32 is the same as 32 over 100. And 32 is then again the same as 16 times 2. We have a square root, and for this one, it is the same as 18 over 100, and 18 is the same as 9 times 2. We have a square root like this, so when we simplify this, we have 16 is 4, 100 is 10, and there is root 2. For this one, 9 becomes 3, 100 becomes 10, and there is square root of 2. Since we are multiplying this by root 2, this and that cancel out each other. So we're left with this expression only. 0.4 over 4 over 10 plus 0.3 over 3 over 10. So 4 times 0.1 is 0.4, and we have 0.1 over here too. So 0.1 times 10 is 1. So our answer is 2. Let's simplify this expression so that we have this and that. If we factor out x, we have y minus z, and if we factor out minus y, we have y minus z, and we have z minus x over here. Okay, we can further factor out y minus z from this expression. So we have y minus z times x minus y plus z minus x. So x minus y is given to be 3, y minus z, we don't know. We can find this out. So when we subtract this two, we have minus y plus z is equal to 1. So we want to find out y minus z. So y minus z is minus 1. And z minus x. X minus z is known, so z minus x is minus 2. So our answer is minus 3 minus 2, which is minus 5. The answer is D. 22. There are two second order equations inside this expression. So let's rewrite this as x squared plus, instead of 4x, we're going to write 2 times x times 2. Since we have 2 over here, we'll add 2 squared. In order to not change the value, we're going to subtract it again. So minus 2 squared. So the first part is done. The second part is y squared plus, since we have minus 6y, so it's minus 2y times 3 to have minus 6. So since we have 3 here, we're going to add plus 3 squared. In order not to change the value, we're going to subtract it again, minus 3 squared. So what's left over here is plus 13, which is equal to 0. So this expression is the same as x plus 2 the whole square, and that expression is y minus 3 the whole square. So what's left is minus 2 squared, which is minus 4. This is minus 9. The summation of these two cancel out with 13. So we have x plus 2 the whole square plus y minus 3 the whole square is equal to 0. From here, we have x is equal to minus 2 and y is equal to 3. So x plus y is minus 2 plus 3, which is 1. So the answer is C. 23. A, B, and C are given this way, and we're asked to find the order from the largest to the smallest. So it's a little bit difficult to make the comparison as they are. So I'm going to square both sides of this expression. So A squared is 14 plus 5 plus 2 times 14 times 5 is 70. So B squared is going to be 13 plus 6 plus 2 times 13 times 6, which is 78. For C squared, we have have 15 plus 4 plus 2 times 15 times 4, which is 60. Now they're all equal to 19. So we can make the comparison easily now. The largest is 78. So b squared is the largest, and the second largest is a squared. The third largest is c squared. Since they are all positive numbers, we can say that b is greater than a, which is greater than c. So the answer is D, 24. The ratio is given. What is the value of a if a plus b plus c is 44? Let's say the ratio is equal to k. So we know that a plus b plus c over 0.2 plus 0.4 plus 0.5 is also k, and this is given to be 44. So we have 44 over 1.1, which is 40. So k is 40. What is a? A is equal to 40 times 0.2. So the answer is 8. 25. A, b, and c are negative integers, and this expression is given. Which one of the following is maximum of a plus b plus c? We'll first start with finding the LCM, least common multiple, of these three. So LCM of 4, 6, and 12 is 12. So that means this expression is equal to 12k, and a is 3k, b is 2k, and c is k. So a plus b plus c becomes 3 plus 2 plus 1, 6k, and the maximum in the given answer choices is negative 36. Although negative 48 is also divisible by 6, since b is larger, our answer is going to be negative 36. 26. A is an integer in the given expression. P of x is a polynomial. What is it equal to? So to be a polynomial, first of all, the power of x must be natural numbers. So 3a plus 5 over a can be simplified to 3 plus 5 over a. For this to be a natural number, 5 over a must be an integer. So 5 over a is an integer, so a can be 1 and 5. And it could also be minus 5, and minus a must also be a natural number. So a cannot be a positive number anymore. So that means the only possible choice is a is minus 5. So when a is minus 5, we have x to the 5, and this is minus 5. It becomes minus 1. 3 minus 1 is 2. So plus 2 x squared plus 4. So this is our polynomial p of x. So the answer is A. 27. The polynomial p of x is given, and q of x is also given in terms of p of x. What is the sum of the coefficients of q of x? So here, what's important is the term sum of the coefficients. Let's say q of x is ax squared plus bx plus c. The coefficients are a, b, and c. So the summation of coefficients means q of 1, which is a plus b plus c. So that's the idea. We're asked to find q of 1, but from this expression, q of 1 is p of 1 over 0. Since the denominator is 0, q of 1 is undefined. So the only way q of 1 can exist is p of x is a factor of x minus 1. So that means p of x is divisible by x minus 1. So when p of x is divisible by x minus 1, we know that p of 1 has to be 0. So p of 1 is 4 times 1 plus a minus 5. So from here, a minus 4 is equal to 0. So a is 4. So we know this. Now we can factor this out as xx and minus 5 times 1. Since a is 4, this one is positive and this one is negative. So we have x plus 5 and x minus 1. So p of x is x plus 3 times x plus 5 times x minus 1. And these two cancel out each other. We have q of x is equal to this two, the multiplication of these two. So q of 1 is going to be 4 times 6, which is 24. So the answer is E. 28. We have two sets, m and n. Let's say this is m and this one is n. The intersection of the two sets is 4, and the number of the elements of the union of the two sets is 11. So let's say this is x and this is y. So to write down this equation, x plus 4 plus y is equal to 11. So this is the union of m and n. So from here we have x plus y is equal to 7. And we're given that n is not a subset of m and n is not a subset of m. That means they're not inside each other. So what is the maximum number of subsets of m? So to maximize this x plus 4, y has to be minimum, and y cannot be 0. If y is 0, it'll be inside m. which is gonna violate this expression here. So the minimum value for y is 1, so x is 6. If x is 6, x plus 4 is 10. That is the number of the elements of M. And we're asked to find the number of subsets of M. So to find the number of subsets, the formula for this is 2 to the n being the number of elements of M. So the answer is 2 to the 10. D. 29. In the same universal set, these expressions are given. We're asked to find the number of elements of set A. So let's sum up the first two expressions. We know that the summation of number of the elements of set A and number of the element without set A is the universal set. So let's say universal set is E, the number of elements of universal set is SE, plus the same situation here. The number of elements of set B plus the number of elements of set without set B makes a universal set. So we have two universal sets, and the summation over here is 56. From this expression, we have SE is equal to 56 over 2, which is 28. And SA prime is given. SA prime is SE minus SA, which is given to be 13. We know SE is 28, so SA is 28 minus 13, which is 15. The answer is D. 30. For the function to be a constant, what should be the value of M? So f of x is a constant function. Using the properties of ratio, we can write this expression as this. From here, we have, since x cancel out each other, m plus 1 over m is equal to 4 over 5. We can solve for m as 5m plus 5 is equal to 4m. M is equal to minus 5. So the answer is A. 31. The shaded area over here is F. To find the shaded area, we need to take away the smaller triangle area from the larger triangle area. So to find out the area of the smaller triangle, we need to know the height of that triangle, which is the y coordinate of the intersection point over here. To find out the intersection point, we need to solve for the equations of the two different lines here. So let's start with the equation of the first line. Y is equal to mx plus c. M is the slope here. So the slope is rise over run. So it's 1 over 1. So m is 1. So we have y is equal to x. C is the y-intercept when x is 0, which is here. So we got the first equation. For the second equation, we can find the slope from rise over run, which is 4 over 6. And point C is, again, the y-intercept when x is equal to 0, which is 4. So we got our equation 2 over 3x plus 4. Since the slope is a negative slope, we need to add a negative over here. So we need to find the y-intercept of the intersection point. So I'll substitute the x value. X is equal to y plus 1, and let me substitute this value over here to the second equation, minus 2 over 3 times y plus 1 plus 4. I'm going to multiply both sides by 3, so we have 3y is equal to minus 2y minus 2 plus 12. So we have 5y is equal to 10, y is equal to 2. So that's the y-intercept over here. So we can find out the area of the smaller triangle now. The base is 5, so half base times the height is 2, so the area is 5. For the area of the larger triangle, the base is 6, height is 4, so we have half base and height. It's 12. The shaded area is the difference between the two areas. 12 minus 5 is 7. 32. A, B, C, D, E, F is a regular hexagon. So all the sides are equal. And the area of the triangle BDF is this. So this is given as 3 root 3. And since these three sides are the diagonals of the regular hexagon, they're all equal. So we have an equilateral triangle here. The area formula for the equilateral triangle is half base is, let's say, BD, height is root 3 over 2 BD, and the area is given to be 3 root 3. So root 3 cancel out each other. We have BD squared is equal to 4 times 3, so BD is 2 root 3. This is known. And we also know that in a regular hexagon, each angle is 120 degrees. Since the sides are equal, this one is 30, that one is also 30. In the 120, 30, 30 triangle, we know the side length ratios. It's 1, 1 root 3. Since we have got 2 root 3 over here, the sides are 2 and 2. And we're asked to find the perimeter of the hexagon. So the perimeter is 2 times 6, so the answer is A. 33. The area of the triangle ABC is 9 root 3. This is the regular hexagon, and we're asked to find the shaded area. Okay, so since this is a regular hexagon, each angle of the regular hexagon is 120. So this is 120. That means this one has to be 60. We also have the same situation here. So this one turns out to be an equilateral triangle. The three sides are equal. Since this is a regular hexagon, this length and that length is also the same. And we also have the same situation here, 120, 60, 60, 60. So that means this side lengths are all equal. So this is 60, that is 60, so this is 60, and this side lengths are equal. So we have an equilateral triangle with side length 3x, x being this one. So the area is given 9 root 3. The area for equilateral triangle is half base height is root 3 over 2 times one side. Root 3 cancel out each other. We have 9 times 4 over 9 is equal to x squared. From here x is 2, and we know that the regular hexagon is made up of 6 equal equilateral triangles. So the total area of this shaded region is 6 times this area. So this area is half, and base is x, which is 2, and height is, since it is equilateral, we have this height. Let's simplify this to cancel out each other. We have 6a is equal to 6 root 3, which is the entire area of the regular hexagon. So the answer is D. 34. In the figure, 80 degrees is given here, and PT and PC are equal. The angle ABK is asked. Let's say the ABK angle is X, and we know that the angle between the interior bisector and exterior bisector is always half of the angle on the other side. So this is 80, this one has to be 40. And PTC is an isosceles triangle. So these two angles are the same. If this is 40, this has to be 70, and that one is also 70. So this is also 70, since these two angles are the same. So in this triangle, we know that the summation of the two interior angles is the same as the exterior angle over here. So 80 plus x is equal to 140. From here, x is equal to 60. The answer is B. 35. In the figure, 3 bisectors are given. One is over here, one is there, and the last one is here. Let's name the angles. Let's say this is theta, and this one is alpha, and this one is delta. Since the summation of 2 alphas and 2 theta is 180, we know that alpha plus theta must be 90. And since x is here, we know that it's also x because it's an opposite angle. So x plus y must be 90. We're asked to find x minus y. We also know that in this triangle, the summation of the interior angles 2 delta plus 2 alpha is equal to 180 minus 36. From here we have delta plus alpha is equal to 90 minus 18, which is 72. And we also know that from this triangle, delta plus alpha is equal to x. So this one is x. Since x is 72, y must be 18. Since we are asked to find x minus y, the answer is 72 minus 18, which is 54. 36. In the figure, the interior bisector and the exterior bisectors are given, and 12, 15, 10, the side lengths are given, so the figure is complete. We're asked to find x plus y. So from the interior bisector theorem, we know that 15 times x is equal to 12 times 10. We can find x as, since 5 times 3 is 15, 5 times 2 is 10, 3 times 4 is 12, so the x is 8. And from the exterior bisector theorem, we know that the multiplication of this two, 10 times 15 plus y, is equal to the multiplication of this and that. So y times 12 plus x, x is 8, so y times 20. 10 times 2 is 20. From here, y is 15. Since we're asked to find x plus y, the answer is 8 plus 15, which is 23. 37. In the figure, ABC is an equilateral triangle and ADC is an isosceles triangle. So let's write down the angles. Since this is 120, This is 30 and that is 30. Let's say if this is x, we have 120, 30, 30 triangles. So this one is root 3x. So the side lengths are all equal, so they are root 3x. We're asked to find AD over BC. AD is x and BC is root 3x. So the answer is 1 over root 3, which is the same as root 3 over 3. D. 38. AB is equal to AC. It's given in the figure. And 120 and 8 root 2 over here, we're asked to find the area of this triangle. So let's draw a perpendicular line from A to BC. Since this is an isosceles triangle, the height divides the base into two equal parts. So we have 4 root 2 over here, and we have a bisector here too. So this one is 6. Since this is 60, that has to be 30. So a special triangle is obtained. The opposite side of 30 is, let's say, x. The opposite side of 90 is 2x, and this one has to be root 3x. So we need to find x to be able to find the area of the triangle. Root 3x is equal to 4 root 2. From here, x is equal to 4 root 2 over root 3. So the area of the triangle is half base is 8 root 2, and the height is 4 root 2 over root 3. Root 2 times root 2 is 2. 8 times 4 is 32 over root 3. When we rationalize it, we have 32 root 3 over 3. So the answer is 9. The two tangents are given, and this angle is 70. We're asked to find x. Let's say the center is here, and when we join the center and the tangent point, we know that this is 90 and that is 90. So the central angle would be 110, so that the summation becomes 180. So if this is 110, we also know that the angle here is half of the central angle. So it's 55, and 55 plus x is 180. So x is 125. The answer is D. 40. Two angles are given, 50 and 120. ADB, this angle is at. So let's say this one is x. So this is 180 minus x. And if this is 120, that one is 60. And if this is x, we also know that that one is also x. So this is also 180 minus x. So this is a quadrilateral. The summation of interior angles of a quadrilateral makes 360 degrees plus 50 plus 2 times 180 minus x is 360. From here, the only unknown is x. We can find it. So 180 minus x is 360 minus 110 over 2. This is 250 divided by 2 is 125. So x is 180 minus 125. The answer is 55. B. This is the end of the math part of the exam. I hope you get something out of this. See you in the next one.